Hi, this is Mr. Heier again. We're going to talk more about acceleration in this video. In particular, we're going to talk about the equations for constant acceleration. You can use these anytime the acceleration stays constant. All right, so there's four of them. And these four equations, if you look at them, look at each one separately, they have different unknowns in them. The first one, number one, is VF equals VI plus AT. VF is V final, VI is V initial. So VF, final velocity, equals VI, the initial velocity, plus AT, the acceleration times the time. The second equation, D, the displacement, is equal to VIT, initial velocity times time, plus 1/2 the acceleration times the time squared. The third equation, doesn't know if you notice, doesn't have time in it, and it's V final squared equals V initial squared plus 2AD. Right? And that's 2 times the acceleration times the distance. Right? And then the fourth equation, we really don't use a whole lot. In fact, some teachers don't use it at all. But in case your teacher likes to use it, I'm going to go ahead to include it. It's that the displacement D is equal to 1/2 VF plus VI all times T. Notice this equation doesn't have acceleration in it. Right? So we would use these equations to calculate one of the unknowns. All right, so before I get into some examples, I just want you to see where at least one of these equations come from. They all kind of come from substitutions with each other, with what we already know, but I'm going to show you how we actually get the first equation, equation number one. All right, so we know the definition of acceleration is delta V over time, and delta V is V final minus V initial over time. So we say acceleration is equal to V final minus V initial over time. And if we multiply both sides by time, we get VF minus VI equals A times T. And then we just add VI to both sides, and we get the final equation. VF is equal to VI plus AT, which is what we got here at number one. Okay, and then basically you can get all the other ones by doing substituting some of the equations that we already know. But you're not going to have to do this in class. But I just thought it'd be good for you to see that these are just not these equations just don't magically appear. All right. So now, which one of these am I going to use? All right. So what you're going to do is you're going to write down all of your givens, including your unknown, the question mark variable. Write all of them down, what you know, and then that will be the equations. Those are the variables that you're going to have to work with. Then you're going to look at those four equations and find the one that has all of those variables and only those variables in it. You'll write that equation down, plug the numbers in, and you'll solve. All right, so let's look at some examples. Okay, so number one, a cheetah can accelerate from rest to 27 meters per second in 3 seconds. What is the acceleration? All right, so the unknown, what we're looking for is A. So that's our question mark. What else do we know? It says it can accelerate from rest. If something is at rest, what's its initial velocity? Right? That would be equal to 0. A lot of people get that confused because it doesn't specifically say 0. So you'll have to be able to read that into there. Okay, so it goes from rest to 27. So it looks like that maybe final is going to be 27 meters per second. And then it says in 3 seconds. And so what is 3 seconds? That's the time. So that's 3.0 seconds. All right, so we are dealing with A, VI, VF, and T. Which of those equations deal with just those variables? All right, so if you look at it, take a second, then you know it's going to be VF is equal to VI plus AT. And then we can just plug our numbers in. All right, VF is 27. That's equal to 0 plus A, which we don't know, times 3. And so if we write it all out here, it's 27 is equal to 3 times A. Divide both sides by 3. And my A is going to be 9 meters per second squared, which is a very large acceleration. Cheetahs can accelerate incredibly fast. All right, so that's the process that you're going to use every single time. So let's look at another one. It says a car is traveling at a speed of 20 meters per second. It accelerates at a rate of 3.2 meters per second squared for 1,750 meters. What is the final velocity of the car? So obviously the final velocity here is what we're going to be looking for. So VF is our question mark. Okay. It's traveling at a speed of 20 meters per second. Well, the only other velocity that we have is initial velocity. So that must be my initial velocity, and then it speeds up. So it's 20 meters per second. It accelerates at 3.2 meters per second squared. So that's our acceleration. You can also look at the units to figure out what these things are, even if it doesn't make sense in the wording, because we know the unit for acceleration is meters per second squared. So we know that has to be meters per second squared. Now this is for 1,750 meters. All right. Now, we don't necessarily know, when we say for this, we don't know this is distance or displacement, but we actually do because, well, what are the units? The units are in meters. So the distance displacement is going to be 1,750 meters. So what equation deals with VF, VI, A, and D? No time. All right, that's the third equation. VF squared equals VI squared plus 2AD. Right, we're looking for the final velocity, so we don't know that. So VF squared is equal to 20 squared plus 2 times 3.2 times 1,750. And if we plug this in the calculator, 20 squared, so VF squared is 400 plus then 2 times 3.2 times 1,750. That's a big number, 11,200. So VF squared is 11,600, right? And then how do we find the final velocity? Since final velocity is squared, we take the square root of both sides. And we get our final answer for the final velocity as being 107.7 meters per second. And then let's look at one more, and then you'll practice some on your own. Okay, so a racing car initially at rest accelerates uniformly at 10 meters per second squared. That should be a squared there. Sorry, I mistyped that. So that should be 10 meters per second squared for a distance of 100 meters. For how long did the car accelerate? All right, so for how long? Anytime you see or how long did something happen, we're looking for the time. Okay, and then what else do we know? We know the displacement is 100 meters. We know that it starts from rest, so that's my initial velocity being 0. And we know the acceleration is 10 meters per second squared. All right, so we look at this and we try to use, let's see, which one has all these four things and nothing else, and that's equation number 2, which is D equals VI times T plus 1/2 AT squared. Right, and then we just plug in our numbers. 100. My VI is equal to 0, so 0 times T plus 1/2 times 10 times T squared. Right? That could be scary at first because we have T in two different places. But what is 0 times T? 0 times T, 0 times anything is 0, right? So this comes out to be 100 equals 5 times t squared. Right? And then we take a couple of steps to get rid of to solve for t. First thing we do is we divide both sides by 5, and we get t squared is equal to 20. Then we take the square root of both sides. We get our final answer being 4.47 seconds. All right. Now you've got a practice sheet, and I want you to, you're just going to need to practice a lot of these. The more you practice, the better you will get at it. And you will hopefully will get quite good at it.